Namaste, myself Shivanandappa H Doddagoudar. In this video lecture, I am going to take a BSc third semester mathematics paper 2. In that paper, I am going to deal with that chapter real analysis. In that topic itself, I am going to take a Lagrange's method of undetermined multipliers. Theorem 1, explain the Lagrange's method of undetermined multipliers to find the extreme values of u is equal to f of x comma y comma z subject to the conditions pi 1 of x comma y comma z is equal to 0, pi 2 of x comma y comma z is equal to 0. Proof of that one it is u is equal to f of x comma y comma z, pi 1 of x comma y comma z equal to 0, pi 2 of x comma y comma z equal to 0. You can call this one as equation 1. For maxima or minima of u, we have du is equal to dou u by dou x into dx plus dou u by dou y into dy, dou u by dou z into dz. d pi 1 is equal to dou pi 1 divided by dou x into dx, dou pi 1 divided by dou y into dy plus dou pi 1 divided by dou z into dz. d pi 2 is equal to dou pi 2 divided by dou x into dx plus dou pi 2 divided by dou y into dy plus dou pi 2 divided by dou z into dz. Now multiplying these equations 2, 3 and 4 by 1, lambda and mu, and adding where lambda and mu are the constants here. Now writing that one is next 1 into that equation 2, lambda into equation 2, 3, mu into equation 4 it is. That implies you bring that dx terms one side, dy term one side and dz term one side. Since lambda and mu are the arbitrary constants, we have that dou u by dou x plus lambda into dou pi 1 by dou x plus mu into dou pi 2 divided by dou x is equal to 0, dou u by dou y plus lambda into dou pi 1 divided by dou y, mu into dou pi 2 divided by dou y is equal to 0, dou u by dou z plus lambda into dou pi 1 by dou z plus mu into dou pi 2 divided by dou z is equal to 0. From these equations and the given conditions, we can determine the multipliers lambda, mu and the values of x, y, z for which the maxima and minima of u are possible. Now the working rule it is, working law. Let u is equal to f of x comma y comma z. Instead of pi 1 of x comma y comma z, here I have taken g of x comma y comma z equal to 0. Instead of pi 2, we have taken h of x comma y comma z equal to 0. We should write that capital F is equal to f plus lambda into g plus mu into h. Calculate that capital F x equal to 0, capital F y equal to 0, capital F z is equal to 0. Solve these for x, y, z, lambda and mu. The values of x, y, z are the stationary values. Now the theorem 2 it is, explain the Lagrange's method of undetermined multipliers to find the extreme value of u is equal to f of x comma y comma z subject to the condition pi of x comma y comma z is equal to c. Now proof of that one is u is equal to f of x comma y comma z, pi of x comma y comma z is equal to c. Call this one as equation 1. For maxima or minima of u, we have du is equal to dou u by dou x into dx plus dou u by dou y into dy plus dou u by dou z into dz. d pi is equal to dou pi by dou x into dx, dou pi by dou y into dy plus dou pi by dou z into dz. Multiplying these equations 2 and 3 by 1 and lambda and adding, here lambda is the constant here, we are getting that equation 2 plus lambda times the equation 3 here. Then again bring the dx term one side, dy term one side, dz one terms. We have those coefficients of dx, dy, dz are equal to 0. From these equations, the given conditions, we can determine the multipliers lambda and the values of x, y, z for which maxima and or minima of u are possible. Now working rule for that one is, here u is equal to f of x comma y comma z, g of x comma y comma z is equal to c, capital F is equal to f plus lambda g. Then calculate f x equal to 0, f y equal to 0. Now that is f z is not, f z is equal to 0, we have to calculate solve for x, y, z and lambda, and the values of x, y, z are the stationary values. Now these are the some references here. Now thank you very much.